If you are coming from Windows environment, the way that Linux represents and manages storage devices will look rather different to you. So you already seen that the file system has no physical representation of the drive like C, D or E system in Windows, but rather has a file tree structure, starts with slash at the top here, or the root here of it. So this chapter takes a look at how Linux represents storage devices such as hard drives, flash drives, and other storage devices. We first look how additional drives and other storage devices are mounted upon the file system, leading up to the root here, and root directory mounting in its context simply meaning attaching drives or disk to the file system to make them accessible to the operating system. So for you as a hacker, it's necessary to understand the file and storage device management system, both you on your own system and out on the system of your target. So hackers commonly use external media to load data, hacking tools, or even their operating system. Once you are on your target system, you need to understand what you are working with, where to find confidential or other critical files, how to mount a drive to the target, and whether and where you can put those files on your system. So we will cover all of these topics, so plus how to manage and monitor storage devices in these lectures. Actually, I think this lecture will be one or two lectures, so no more than two lectures here in file system about Linux. So actually, I want to show you an image from internet here. So we begin with directory known as dev here. DuckDuckGo here. So we begin with the directory known as dev, which you probably already noticed in the directory structure. So dev is short for device, and every device in Linux is represented by its own file within dev directory. So let's start by working with dev, but I want to show you the Linux file structure. Linux file structure here. Can you see my screen actually? Yes, right? Yes. So here I want to show you a little representation for presentation for better understanding here. Here. Actually, it's good too here. So I choose two pictures for you here. So let's open this as well here. So here, as you can see here, we have the root directory, all of these folders here, and we have boot. As I said to you earlier, all things in Linux is file. So we have boot directory, bin, dev, etc, home, lib, lost found, media, mount, opt, sbin, serve, tmp. We have user, which is the usernames of our users, and we have another local here as well, and we have var here. So boot, as written here, boot is the system files including kernel. Bin is binary for user. Dev is device files and drivers. etc here is host specific configuration file. Home is user home directories. Lib is shared libraries, kernel modules here. Lost found is unknown files. So media is here. Mount points for removable media. MNT, mount point for temporary file systems. We have OPT here is optional software packages. SBIN here, system binaries. SRV here, data for services provided by the system here. TMP, temporary storage space. User applications like source code, images, and etc. we have in user we have local share bin and lib folders inside of it. So local is installed for local user, share is config files, graphics for user applications, bin is essential system applications that for user here, and we have bin, which is user commands, and lib is shared libraries by user. So we have, lastly, I want to talk about you is var here. Var, we have var run, log, tmp here. So var here, variable data used by the system, run is info about current boot session, log is log files, log is log files, and tmp long-term or large temporary files here. So we have another representation here as well that I want to show you is a boot dev here. We talk about them, and as you can see we have this scheme here. So first I want to talk about is the dev directory here. So Linux has a special directory that contains files actually representing each attached device. So the appropriate name is div directory here. So actually let's here, so we are the top of our file system here, as we discussed earlier, bin, boot, dev, etc, home, lib, like media, mnt, root, run. If you are not using Kali or Ubuntu or another system, yeah, these folders might different on your system here. So as your first introduction, navigate the div directory, cd div here and ls here. So as you can see here, we have so many folders in it. So I will explain all of this here. So you should see something like that, or let's lsla here, as you can, or ls actually lsl is okay. So as you can see here, we have so many folders in it. tte here, we have port here, null, part port, pc, aux here. So I will talk about all of them. So the devices are displayed in an alphabetical order by default. So you may recognize some of the devices such as CD-ROM here, CD-ROM here, CD-ROM here, and we have CPU here as well, charge core here, CPU DMA latency here. So but others have rather cryptic names here. So each device on your system is represented by a file in the div directory here. We are working with it. So including devices you have probably never used or even not realized they existed here. So the of Chengyu 2, so there is a device file waiting to be used for it. So if you scroll down a screen a bit, you should see more listings of devices of particular interest. Are the devices starts with SDA or STB here. Is it like SDA, STB, and other here? As you consider SD1, SDA, SD1, SD2, SDA1, 5 actually. So SDA, SDA1, SDA2, and SDA5. So which are the hard drive and partitions used, and USB flash drive and partitions here. So I have not attached USB drive to this system. So if you attached a USB system, I think it will show you STB here. So STB1 or STB2. So how Linux represents storage devices. So Linux uses logical labels for drives that are then mounted on the file system. So these logical labels will vary depending on where the drives are mounted. Meaning the same hard drive might have different labels at different times, depending on where and when it's mounted. Originally, Linux represented a floppy drives. Remember this, right? So as FD0 and hard drives as HDA. So you will still occasionally see these drives representation on legacy Linux system, but today most floppy drives are gone, thank goodness here. And even so, all legacy hard drives that use the IDA or EIDA is interface are still represented in the form of HDA. So a newer serial ATA or SATA interface drives and small computer system interface SCSI hard drives are represented as SDA here. So drives are sometimes split up into sections known as partitions, which are represented in the labeling system with numbers, as you will see here. So when systems have more than one hard drive, Linux simply names them serially by incrementing the last letter in alphabetical order. So the first drive is SDA, so this means I have one drive because I don't have SDB here. So and the second drive is SDB if you have USB, and third drive is STC, and so on. So the serial letter after SD is often referred to as the major number. So we have drive partitions here as well. Let's look at actually. So I will stop video here. So I'm waiting you in next lecture.